everyone. This is Professor Jeff Wilkerson at Luther College, talking to you once more about what to look for in the night sky this time for the week of May 24th, 2021. We've spent a good deal of time recently looking at the region of the sky that we associate with the evening in spring. A lot of this is Leo, Virgo, and Boötes with Arcturus right there. And we're going to talk more about all of these, but we're going to zero in a little bit on Leo this week. If you had a chance to watch the video last week and get out and look at the sky, you hopefully got to see the moon pass very close to some of these stars and help you identify some of these stars. And we're going to look at 3 stars particularly in Leo this week. Leo is this triangle of a tail back here and a backward question mark or a sickle for a head of Leo. And we're going to look at Regulus, Denebola and Algieba, alpha, beta, gamma stars. So stars and constellations are given Greek letters, and generally speaking, the alpha star is the brightest, the beta is the second brightest, gamma is third brightest, delta is fourth, and so on. Now, they were given these letters sometimes before we were able to measure precisely how bright these stars were, and so sometimes they're a little bit out of order. And so our current brightness measurements would suggest to us that we would actually letter these slightly differently. And for our case, right here, Denebola in the tip of the triangle, the beta star in Leo, is almost exactly the same brightness to your eye. When you look at it, you're going to see almost exactly the same brightness as Gamma, Leonis, Algieba. So those two look almost identical to you brightness-wise. Regulus is noticeably brighter as the alpha star. Regulus is often listed, typically listed as the 21st brightest star in the sky. So it's very common to find lists of the 20 brightest stars in the sky, and Regulus just missed that list, just failed to make the podium. Tough luck, Regulus, maybe next time. Regulus is about a little over 75 light years away from us, a relatively close star, but not as close as Denebola. Denebola is about twice as close. Denebola is about 35 or 36 light years away from us, and Algieba is even further away than either one of those two. They're all relatively close stars. Often the bright stars are. That's why they appear bright to us. Algieba is somewhere in the neighborhood of 130 light years away from us. So about 3 times, a little more than 3 times further away, 3 to 3.5 times further away than Denebola is. So these 2 stars look almost identically bright. I mean, really close. You have to measure carefully to tell that they aren't the same brightness. So if Denebola and Algieba look almost identically bright, and yet Algieba's 3.5 times further away than Denebola, that tells you Algieba is a much more intrinsically bright star. It's glowing a lot brighter. Now, it's a little bit tricky because Algieba is a binary star, 2 stars in orbit around each other with a period of about 500 years. So we can see these 2 stars, and I recommend, that's going to be our highlight for this week. I recommend going out and using a small telescope, maybe good binoculars if you have good binoculars, to try to see if you can see the companion star here. You can see this as 2 stars with somewhat different color. Now, if you read about this, you'll see people arguing about what the different colors of those stars are. So we're not even going to try to, we're going to leave it to you to decide what colors do you see. This is a fun test to go out and try to identify this binary star. The stars are about 4 1/4 arcseconds apart in this binary system. And they have a little bit of brightness difference. So there's a good bit of brightness difference, which allows you to see the 2 stars fairly clearly. A little bit of color difference that allows you to see them as 2 stars and make them sort of pop for you. 4 1/4 arcseconds isn't a ton of separation. It's enough that you should be able to see it, especially in a small telescope. But it's not a big separation. So an arcsecond, 1 degree. Here's our introduction to angles right here. 360 degrees in a circle. Okay, so 1/360th of a circle is 1 degree. You take 1 degree and divide it by 60, and you get an arc minute. So an arc minute is a 60th of a degree. You take an arc minute and divide it by 60, and you get an arc second. And so an arc second is a 60th of an arc minute, or 1/3600th of a degree. So it's a very small fraction of a degree. Hold your finger out at arm's length like that, and that's about a degree that you're seeing right there. And so you see that degree, and 1/3600th of that is an arc second. So 4 1/4 arc seconds is a pretty small separation. Now, what makes it smaller? Okay, we're gonna dive in here just a little bit. And so what makes it a little bit tougher for us is that all stars, essentially, all stars that you would see would look to your eye like a pinpoint of light. They're so far away we can't resolve them. We talk about angular resolution being the smallest angle. There's your angle right there. The smallest angle we're able to see. So if we have a star here, one side of the star to the other side of the star, if that angle is smaller than our eye is able to detect, then these two sides are going to merge and it's going to look like a pinpoint of light to us. And so we're going to see that pinpoint of light on the sky. All stars look like pinpoints of light, even in small telescopes. We take our small telescopes. Some of the best telescopes now with adaptive optics can observe the sizes of some of the biggest stars. But you're generally safe saying that all telescopes and all stars look like a pinpoint of light. That angle is too small for us to be able to detect one side of the star from the other side of the star. Okay? Now, the stars don't actually look like pinpoints of light to us, though, because the atmosphere is turbulent and it's buffeting that light around. So the light's coming to us, it's going to look like a pinpoint of light, but it hits the atmosphere, and the atmosphere churns it up. And as it churns it up, it blurs it out. And that's what we talk about astronomical seeing. And astronomical seeing is how much that gets blurred. And for those of us in a deep atmosphere site, a couple of arcseconds is very common. When I take data up on the roof, especially if I'm looking low on the horizon, 2 or 3 or 4 arcseconds is not an atypical, very low on the horizon, it's not an atypical seeing. So a couple of arcseconds, you take the star and you make it a couple of arcseconds wide. So if you take both of these stars and you make them a couple of arcseconds wide, but the center to center separation is only about 4 arcseconds, you see that they start to blur together a little bit on you under some of the worst observing conditions. So to see these two stars, you want to catch them pretty high in the sky, which is what you got in the evening sky right now. So you're looking through less atmosphere up there, but some nights are going to be better than others. And you can go out, you can find sites on the internet that will give you seeing modeling predictions to say how good is the seeing going to be tonight and how likely are you to be able to resolve these. You should be able to resolve these. But it's not as easy as it might at first seem because of the blurring of the atmosphere. So go look at this binary star, recognize that they're orbiting around each other with a period of about 500 years. Now, Regulus, the alpha star, is itself a multiple star system. You can fairly easily, with binoculars and a telescope, see the secondary component there. The B star, it's often called, is 177 arcseconds. If these are separated by 4 1/4 arcseconds, 175, 176, 177 arcseconds is the separation between the A and the B star in Regulus there, and so pretty easy to do. Now, the B star is itself a binary star. The A star is a binary star, but you can't see this companion. We can't see the companion in any telescope, but we can see that it's a spectroscopic binary. We can tell that there are 2 stars orbiting around each other by the lines in the spectra, but that's a story for another day. So that's a star that's got 2 stars there that we can't tell apart. The B star has a companion that is the C star, and it's a couple of arcseconds separated. So it's going to be even more of a challenge to see the separation of the B star and the C star in Regulus than it was to see the 2 stars in Algieba. But give it a try. If you've got a small telescope, by all means, go out and look for it. Then there's often a D star. So if you have 177 arcseconds, this is 4 1/4 arcseconds separating those 2 stars. 177 arcseconds separating A and B down here, and then B and C, I don't remember that exact number, but it's on the order of 2 arcseconds that separates B and C. There's another star out there that's 210 arcseconds. 210 arcseconds that is the D star. And the D star, it turns out, is not part of the system. It's a background star. So it's what we would call an optical alignment. It's an alignment that, so the star is more distant, but it's not part. These stars are all part of the same system in an orbit around there. This star is not part of that system. But a great chance to go out and look at some double stars, some binary stars, and multiple star systems. Remember, Regulus, the 21st brightest star in the sky, is your alpha star in Leo. Denebola is your beta star. Algieba could just as easily have been called the beta star. They are so close in brightness. In fact, a lot of places would call this just over 2.1 magnitude, and this just under 2.1 magnitude. The magnitude system counts backwards. So this, as a single point of light, these 2 stars merged together, actually typically looks a little bit brighter than this, but ever so faintly. A gamma star, Algieba, Go out, see what you can do with Leo. Get to know this part of the sky even better. That's what we're working on this spring, right? We're getting to know one region of the sky and really digging in and studying it, and help us to think about what's going on right there and really appreciate this as a good friend, this part of the spring sky. We'll come back to this and talk about some of the galaxies in this region, maybe as early as next week. Maybe we move on to the stars of Virgo next week, or Arcturus, and talk about the stars in Boades. Maybe we do something completely different, whatever mood strikes us. But be sure to tune in next week and check that out. Be sure to go out and look at the stars of Leo one more time, and you're going to start to feel really comfortable with identifying Leo in this region of the sky. Thanks, everybody. Hope you have good observing this week.